Hello friends, today I want to show you a modern way of state management for Jetpack Compose. You've never seen this before, so stay tuned till the end of this video because I'm going to do a live coding and implement this new approach, then you will learn how to do that. As you may know, in Jetpack Compose, state management is very important. And one thing is recommended is having the Jetpack Compose component stateless and hoisting the state to the upper level. What we are going normally is creating the state in the ViewModel level. And today I'm going to show you how we are doing currently by reviewing a code base. I cloned the code from GitHub and reviewing the code to see how it has been implemented. And just now I'm telling you it is implemented with Kotlin Flow, and combining those and creating a UI state and passing it to Compose component to render the UI. I'm going to first review this code base, then refactor and create another version of that class. And in this new approach, I'm going to use Jetpack Compose API itself instead of Flow. Sounds strange, yes? You have to see how it is in practice. I don't want to keep you long, so let's jump into the Android Studio and look at the code, start digging the code and implementing a new approach. Let's jump in. This is the code example I took from GitHub. It's a task management application. What we are going to do here is mainly with the ViewModel class and seeing how it creating this state and passing it to the UI for rendering. This is where the ViewModel is defined and where the UI state is being used. So let's first review the code to see what this UI state is and how it is being created. Let's get into the task ViewModel class. In this class, we have a task UI state, which is the data class we are using for displaying data on the screen. So let's look at the ViewModel class. We have a save filter type, which is a state flow of task filter type. And it used save state handler to retrieve those data they stored in case of configuration change. The next parameter here is a flow of filtering UI info. It listened to the save filter type flow and creating another type, which it does with the get filter UI info, and it get a request type and return a filter UI info. And there's another flow, which is a user message, and the type is int and it is nullable. And another one is loading, which is another flow. And the next one is a little bit more important, which is getting all the tasks from the repository by calling get task stream from the task repository, and combine this flow. It is a flow of list of tasks, and combining it with saved filter type and create in filter actually the task it's going to be shown on the screen. And the next step is mapping those data and creating a type of async.success. And if there is any error here, it emits async.error. And what we have here for creating the UI state, it combines all of these flows and create one single type, which is the task UI state, and it will be passed to this task screen. Display the data. So you see that this is quite complex if you want to trace and debug the code. There are so many flows, and there's a combine here, there's another combine here to chain all of these together and eventually create a task UI state based on these task async. That's the main thing it's happening in this task ViewModel class. There are some other function is defined, like setting the request type, clear completed task, and some of them are like updating the mutable state flow with the refresh, and same as updating the snack bar message. And that's the function we had above to filter the task. And yeah, that's pretty much it. Yeah, this is a regular function, get filter UI info. Now we see the code. I want to show you the complexity and the boilerplate code these flows create and how hard is that to trace the code. But anyway, this UI state is being created and it's being used here, and it get collected as a state with lifecycle. What I'm going to do is refactor or create a new task view model and implementing it with Jetpack Compose APIs, which is something I found it simpler and easier to track. So stay tuned to create these new class. I created a new file here and I'm going to split the screen to rewrite the code one by one. Okay, let's start with just first adding the health view model annotation and adding the inject to being able to inject these parameter task repository and saved state handler and extend the class from ViewModel. One thing I would like to do before starting, create an extension function for the ViewModel and to execute any coroutine. I don't want to, let me show you here, call ViewModel scope, where was that? Yeah, ViewModel scope.launch every time. And what I'm going to do is just simply create a launch extension function and pass a coding block of a suspend function to this function and call this function here. Now, if, for example, if I want to call that, I simply call this instead of every time calling ViewModel scope.launch. Anyway, I'll use it later on. Let's continue our work with what we have here at the top. To have the saved filter type as a composable state, I need to create a variable and call it saved filter type. And by helping delegate, I want to create a mutable state of from saved state handler, and the key is task filter saved state key. And because it could be null, the default value will be all tasks, and I need to import all the required functions to be able to make use of this mutable state. So I have the first state instead of a flow for saved filter type. What is the next one is filter, or let me create the user message. I'll get to filter UI info later. Again, I need to create a variable user message by mutable state of an nullable integer, and the default is null. And I'm going to skip these parts for now, and I want to do this set filtering function and just exact signature. So what I am going to do is set the saved filter type to request type. No, actually the name is not accurate. I set it filter type and update the saved state handler and setting to this key filter type. And then next, let's do the clear completed task. I created launch function. This is one use case. I can make use of that to call this suspend function and show the snack bar. I have to create this function as well. And let me set the R class and pass this completed, and at the end calling the refresh function. So let me create these two functions as well. Show snack bar, and it need a message ID, which is an integer. Let me add a to do and for the refresh as well. Let's do the complete task. I'll complete these a little bit later, and those complete tasks, which is a bit more independent. What we have here is a task and a boolean of completed. Again, let me use launch function since we are going to execute some coroutine function. I check if it's completed to the task repository. No, not this one. Task repository dot complete task and passing the task.id and showing a snack bar message, which is our string dot task marked complete. In the else part, we set the task as active task and passing the ID again, and show another snack bar message, which is task marked active. The next function is show edit result message and passing result a type of integer and setting a when statement. If it's edit result, should show snack bar message with the ID of successfully saved, and if it's add edit result okay, show another message which is successfully added. And the last one, if it's deleted, we show deleted message. To clear the snack bar message, we need this function, which is snack bar message shown, and user message is null. What is the next one is private function of show snack bar message, which we used it a couple of times. It has a message ID and updating this user message to message ID. Yeah, I already defined it here, but that's fine. What is next? Let's do the filter tasks function. Filter tasks, it accepts a list of tasks and filtering type, which is tasks filter type. And what I want to do, I would prefer to use when statement to pass the filtering type, and let's quickly create all the branches this way. Okay, when I complete these to-dos, it will be fine. If a task is all, simply return all the tasks, which is obvious. If it's active, tasks dot filter it dot active. And if it's completed, same thing, filter dot it completed. Okay, I think we proceed good amount. Let me see what I have missed. Filter UI info, which I said earlier, it is this one, but I'm going to create a compose state instead of flow. So one thing I would like to do, which is something new for in this approach, is I want to depend this filter type to the new state and create the filtering UI info. So I'm going to create a composable function and call it get, let me make it private, get filter UI info. And what it accepts is request type or task filter type. And what it does is produce state. It's an API of Jetpack Compose. It accepts an initial value. What would be the initial value? In this case, I will create a filtering UI info, and the current filtering label is label.all, and the no task label is all no task all, and the icon is from drawable. No, fail. Okay, what is left here? We have to, as you see here, the error message is produce state calls should assign value inside the producer lambda. This is the producer lambda, and I need to pass something to this value. So what I'm going to do is create filtering UI info based on task filter type. So I will update these branches. One thing we need to add here I missed is passing a key. And what is the keys and what does it do? It create new state if the task filter type get changed. Means it will re-execute this piece of code if the task filter type is something new. If we don't pass anything, this produced state will be executed only once. Imagine something like, remember API we have in Jetpack Compose. It acts like that, but if we pass the key, it react based on the task filtering type changes. So for the all task, let me just copy paste this and modify the labels. It for the all tasks is the same. For the active task, label active, and the second one is no task active, and I use check circle. And for the last one, I use label complete and no task completed, and the icon would be verified icon. Okay, I create a state for the filter UI info. You see the return type is a state of filtering UI info. We will use it in a minute when we want to create the final state for UI. So I create another composable function, but this one is not private, it is public, because we want to call this function from composable components. Produce UI state. What the return type is task UI state. And what I'm going to do first, let me create a variable for this final state, which is a mutable state of task UI state. But I need to reassign the valid task UI state to that. I'll create that in this class. First, let me create the list of tasks we have here. Like I want to complete this part first and then go to this state flow and complete that. What I'm going to do first, let me highlight this part and do it here. It's task async by task repository, repository.get task stream. First, map the type to async.success. Let me import the type and having the filter task. I think we already defined this function. Let me put it in the different variable, then it's a bit more clear to you. So what we have to pass, the task, which is it in this case, and filter, save filter type. Let me create a variable here for the sake of simplicity and more readability. Here we have a task filter type. I'm going to pass to this, and I have a list of tasks, which is the filtered one. And at the end, I create a new type of async.success. The same as the Kotlin Flow, I want to catch if there is any error and create a new type of async.error and passing the error message. Let's choose this one. And what we need to do at the end is collect as a state, and the default value is async.loading. That's exactly the same as what we have on the right side. You see, we did everything same, but with the composable states. This is a task state. Let's create the next dependency for creating task UI state. What would be the next one is, I think, filter UI info. Create a variable of filter UI info by get filter UI info. The function is here, and that's the way we create the composable state. And what we need to pass here is filter type. Yeah, and let's update the state variable. So we have to do something similar like this here and add an event condition and passing the task async, and based on that create an instance of task UI state. What we do in the error is create a task UI state with user message task async dot error message. I think there's a casting problem here. I need to define a variable like task result and use the task result instead. It will fix the casting issue. For the loading, I create task UI state with is loading is true, and for the success case, task UI state items is task result dot data, and filtering UI info is filter UI info we just created, and is loading obviously should be false. The last one is user message, which is user message. Let me just quickly create a user message as well. Then we know the way of dependency between these composable states. We have 1, 2, 3, 4 composable state, which help us to create a task UI state and updating that. What we need is just calling this produce UI state to generate all this stuff. And as I said before, these composable states like this or using produce state here will be executed only once, regardless of any recomposition. And there's an exception we define: if we pass a key, it will be updated. That's the different. There's one issue here I need to fix is I don't want to call this piece of code in every recomposition. What I would do is using launch effect. Launch effect help us to execute this part only once or based on some condition or keys we are passing here. Just a pause here. I already have a video on the channel about launch effect, disposable effect, and side effect. If you're not familiar with launch effect, take a look at that video. It helps you understand the launch effect better. And I try to explain in a clear way, in a simple way, then you understand these API in Jetpack Compose, which is kind of important to know how it works behind the scene. Let's back to the code. I want the coding block in the launch effect will be executed only if task async get changed and filter UI time is updated. I think this will be enough for now. Yep, that's all we wanted to implement. I missed the refresh. Let's take a quick look at the refresh function. It's here. And what I'm going to do, use the launch extension function. I don't need to set the loading and the task repository dot refresh because the rest will be done behind the scene. Yeah, that's the refactoring we needed to do. We have different state, composable state here, and we have only one function to kind of do a similar job as combines do here for the Kotlin Flows, but we are doing it with composable states. Let's use this code. Before switching to the new task view model we created, I want to execute the current implementation to see how it looks, and then switch to the task view model version 2 with the help of composable states. This is the application. It's working fine. Let me create like task 2. This is the second task need to be done. And yeah, seems it's working fine. I now going to update this ViewModel class within the task screen. So there's a small change here. I need to call the produce state class. I'm not using delegate, and that's it. Everything else should work fine except this snack bar message is shown. I think I missed this one. Oh, just a typo. Okay, let's execute the new implementation. Finger crossed, everything's fine. Yep, application runs successfully. It loaded the task. Let's check the filtering. Only show the active one, show the completed one, show all, create a new task, task 3. This is my third task today. Everything's working fine, but with the composable states. Yeah, that's what I was going to show you today to make use of mutable state flow and composable state, produce state in ViewModel class. It's something new, and you may wonder why you have to use composable API inside the ViewModel class. Why not? I don't really see any problem with that. And you see that the code is quite simpler. And for some cases, you see a little bit more complex. You have so many flows to combine to each other and tracing, debugging all these, because I had those experience. I'm working with the Kotlin Flow and I see how hard is that to debug those code and understand somebody want to review the code. It's very hard to trace, but with composable states, I found it much easier to read and manage the states and what you want to do. Jetpack Compose is come to help us, and it's a new API. It's not something we may be comfortable to use it in a different way as Google recommend to us. It's something different, but it does work. Why not we use that in the ViewModel class and create our state this way? So please let me know your opinion about this approach, and you may not be agree with that and you may find some problem. Just write it down in the comment section, then everyone else and me be aware if there's any issue with that. We can work on that. But I implement this in enterprise applications. It worked fine. I didn't see any problem. I even tried to create some helper function to make this approach global through the application I implementing. And yeah, hope you enjoyed this content. I'm Ali from the Otaku channel. I have this channel for about more than I think it's getting a year, and I upload videos every 2 weeks about Android development, software development in general, or some kind of soft skill or any essential information any developer would need, like job interviews, resume writing, these kind of topics. If you're interested into such topics, watch those videos, like, and don't forget subscribe to the Otaku channel to be notified about any upcoming videos. And yeah, that's it. Hope you enjoyed the video and see you till next video. Bye.